question of whether a fire pump disconnect counts towards the 6 disconnect rule is a common one. To clarify, the 6 disconnect rule, as outlined in the National Electrical Code or NEC, specifically applies to service disconnecting means. The key here is understanding what constitutes a service disconnect versus a load side disconnect. A service disconnect is the main means of cutting off all power to a building or structure. It's directly connected to the service conductors bringing power from the utility. The 6 disconnect rule, found in NEC section 230.71, limits the number of service disconnecting means to 6 switches or sets of circuit breakers for each service. This rule aims to provide a readily accessible and manageable way to energize an entire electrical system in an emergency or during maintenance. Now, let's consider the fire pump. The fire pump is a critical piece of equipment designed to provide water flow for fire suppression systems. Because of its importance for life safety, its power supply is often required to be exceptionally reliable. This typically involves a dedicated feeder directly from the transformer or another reliable source of power. The disconnect for the fire pump, while essential for maintenance and safety, is typically located at the pump itself and is fed from a distribution panel within the building or directly from the service. This means the fire pump disconnect is on the load side of the service disconnect or disconnecting means. It's not one of the main service disconnects that control the entire building's power. Therefore, a fire pump disconnect does not count towards the 6 disconnect rule. The 6 disconnect rule is solely concerned with the number of service disconnecting means at the service entrance. Since the fire pump disconnect is a load side disconnect, it's outside the scope of this rule. To further illustrate this, imagine a building with multiple tenants, each with its own sub-panel and disconnect. These tenant disconnects, like the fire pump disconnect, are all load side disconnects and do not factor into the 6 disconnect rule. Only the main service disconnects are counted. It's crucial to distinguish between service equipment and distribution equipment. Service equipment includes the main service disconnects, overcurrent protection, and metering equipment. Distribution equipment includes panel boards, sub-panels, and individual load disconnects. The 6 disconnect rule applies only to the service equipment portion of the electrical system. In summary, the fire pump disconnect does not count towards the 6 disconnect rule because it is considered a load side disconnect and not a service disconnect. Understanding this distinction is critical for proper electrical system design and compliance with the NEC. When designing an electrical system, especially one involving critical equipment like fire pumps, it's always best to consult the latest edition of the NEC and seek guidance from a qualified electrical engineer or inspector. They can provide specific interpretations and ensure that the design meets all applicable codes and standards. Now let us dive a little deeper into understanding service versus load side and the implications for the 6 disconnect rule. Firstly, understanding the concept of a service is paramount. The electrical service is the point where the electrical utility provides power to a building or structure. This typically involves service conductors running from the utility's transformer to the building's service equipment. The service equipment includes the main disconnect or disconnects, overcurrent protection, and metering equipment. Secondly, the service disconnecting means are the devices used to isolate the entire building's electrical system from the utility's power supply. These disconnects must be readily accessible and capable of simultaneously disconnecting all ungrounded conductors. The NEC permits up to 6 service disconnecting means per service. This is to allow for flexibility in design while maintaining a manageable number of disconnects for emergency situations. Thirdly, the load side refers to the portion of the electrical system downstream of the service disconnecting means. This includes distribution panels, branch circuits, and individual loads. Disconnects on the load side are used to isolate specific circuits or equipment for maintenance or safety purposes. As previously mentioned, these load side disconnects do not count towards the 6 disconnect rule. One thing to remember is that the NEC addresses the fire pump power supply in Article 695. This article outlines specific requirements for the reliability and separation of the fire pump circuit. The fire pump is often required to have a dedicated source of power, such as a transformer or generator, and its wiring must be physically separated from other building wiring to minimize the risk of fire or other faults affecting its operation. The fire pump disconnect is part of this dedicated circuit, and while it must meet specific requirements for accessibility and labeling, it does not impact the 6 disconnect rule. Let us explore some more scenarios to help solidify your understanding of the 6 disconnect rule. Imagine a large commercial building with multiple tenants. Each tenant has its own sub-panel and disconnect fed from a main distribution panel. The main distribution panel is in turn fed from the service equipment. In this scenario, the only disconnects that count towards the 6 disconnect rule are the main service disconnects. The tenant disconnects or load side disconnects are not considered. Or consider a building with multiple buildings on the same property, such as a campus or industrial complex. Each building may have its own service and service disconnects. In this case, each building is treated as a separate service, and the 6 disconnect rule applies to each building individually. The disconnects in one building do not affect the number of disconnects allowed in another building. Now consider a situation where there are multiple services entering a single building. This is less common but can occur in large facilities with significant power demands. In this scenario, the 6 disconnect rule applies to each service separately. For example, if a building has 2 separate services, each service can have up to 6 disconnects. Understanding the distinction between service and load side disconnects is essential for ensuring compliance with the NEC. Incorrectly applying the 6 disconnect rule can lead to code violations and potentially unsafe electrical installations. It's always best to consult with a qualified electrical professional if you have any questions or concerns about the application of the 6 disconnect rule. When evaluating a specific electrical installation, it's helpful to create a single line diagram. A single line diagram is a simplified representation of the electrical system, showing the main components and their connections. This diagram can help you visualize the flow of power and identify the service disconnects and load side disconnects. By clearly identifying these components, you can accurately determine whether the 6 disconnect rule applies to a particular situation. The NEC provides detailed definitions of service equipment and related terms in Article 100. Familiarizing yourself with these definitions is essential for understanding and applying the code correctly. The definition of service includes the conductors and equipment used to deliver electric power from the utilities distribution system to the wiring system of the premises served. This includes the service drop or service lateral, the service entrance conductors, and the service disconnecting means. The definition of service equipment includes the necessary equipment, usually consisting of a circuit breaker or switch and fuses, and their accessories connected to the load end of service conductors to a building or other structure, or an otherwise designated area and intended to constitute the main control and cutoff of the supply. The NEC also provides rules for the location and accessibility of service disconnecting means. These disconnects must be readily accessible, meaning they must be located so they can be reached quickly and easily in case of an emergency. They must also be marked to indicate their purpose. In summary, the 6 disconnect rule is a specific requirement in the NEC that limits the number of service disconnecting means to 6 per service. This rule applies only to service disconnects and does not include load side disconnects such as the disconnect for a fire pump. Understanding the distinction between service and load side disconnects is essential for ensuring compliance with the NEC and designing safe and reliable electrical systems. When in doubt, always consult with a qualified electrical professional. Let's further discuss the implications of using more than 6 disconnects at the service. Violating the 6 disconnect rule can have several consequences. Firstly, it's a violation of the NEC, which can result in fines or other penalties. Electrical inspectors are responsible for enforcing the NEC, and they will typically require any violations to be corrected. Secondly, having more than 6 disconnects can make it more difficult to energize the entire electrical system in an emergency. In an emergency situation, it's critical to be able to quickly and easily disconnect all power to the building to prevent further damage or injury. Having too many disconnects can make this process more confusing and time-consuming. Thirdly, an excessive number of disconnects can increase the complexity and cost of the electrical system. Each disconnect requires its own wiring and overcurrent protection, which can add to the overall cost of the installation. For these reasons, it's important to carefully consider the number of disconnects required for a particular service and to ensure that the design complies with the NEC. If it's necessary to have more than 6 disconnects, there are alternative solutions that can be considered. One option is to use a main switchboard with multiple sections, each with its own disconnect. This allows for more than 6 disconnects while still maintaining a centralized control point. Another option is to use multiple services, each with its own set of disconnects. This is typically only necessary for very large facilities with significant power demands. In any case, it's important to carefully evaluate the specific needs of the building and to design the electrical system accordingly. Consulting with a qualified electrical engineer can help ensure that the design is safe, reliable, and compliant with all applicable codes and standards. The NEC also addresses the requirements for grouping of disconnects. Disconnects must be grouped together in a readily accessible location. This is to ensure that they can be easily found and operated in an emergency. The NEC specifies the maximum distance that disconnects can be located from each other. The goal is to have all the disconnects in the same location so that anyone trying to energize the electrical system can do so quickly and easily. In addition to the 6 disconnect rule, the NEC also includes requirements for the size and rating of service entrance conductors and overcurrent protection. These requirements are designed to protect the electrical system from overloads and short circuits. The size of the service entrance conductors must be based on the calculated load of the building. The overcurrent protection must be sized to protect the conductors from damage. It's important to carefully consider these requirements when designing an electrical system to ensure that it is safe and reliable. NEC is a complex document, and it's essential to have a thorough understanding of its requirements in order to design and install safe and compliant electrical systems. It is updated regularly to reflect changes in technology and industry best practices. It is important to use the latest edition of the NEC when designing an electrical system. Many jurisdictions have adopted the NEC as their electrical code. This means that all electrical installations in those jurisdictions must comply with the NEC. It is also a widely recognized standard for electrical safety. Even in jurisdictions that have not adopted the NEC, it is often used as a guide for electrical design and installation. The NEC is developed by the National Fire Protection Association, or NFPA. The NFPA is a non-profit organization that develops codes and standards for fire and electrical safety. The NEC is developed by a committee of experts from various fields, including electrical engineers, contractors, inspectors, and manufacturers. The committee meets regularly to review and update the code. The NEC is a consensus-based code. This means that it represents the collective knowledge and experience of the experts and the committee. The code is designed to protect people and property from electrical hazards. The NEC is a living document. It is constantly being revised and updated to reflect changes in technology and industry best practices. It is important to stay up to date with the latest edition of the NEC in order to ensure that electrical systems are safe and compliant. Firstly, the 6 disconnect rule is a critical aspect of electrical safety. Secondly, understanding the difference between service and load-side disconnects is essential for proper electrical system design and compliance. Thirdly, consulting with a qualified electrical professional is always recommended when dealing with complex electrical installations. This ensures that the design meets all applicable codes and standards and is safe for occupants.